Hey guys, Mr. Middleton here. Today we're going to look at similarity in right triangles. In this video, you should be able to simplify radicals and use the skills of the Pythagorean theorem. You should be able to explain what the geometric mean is and find the geometric mean of two numbers. And you should be able to separate the right triangles into three similar right triangles and match up the corresponding parts. Okay, so let's review a little bit simplifying radicals. There's a few ways you might have learned to do this. The way that I teach simplifying radicals is to use a number tree. And basically the rule is to find two numbers that multiply to give you whatever number's up top. Only rule is that you cannot use 1 in your multiplication. So with 147, it's divisible by 3. 147 divided by 3 is 49, so 3 times 49 is 147. 3 is a prime number. I circle that, I'm done with it. To multiply to get 49, 7 and 7. 7s are both prime numbers. Once I get to the point where everything is circled, I have all prime numbers. Then I take those terms, put them underneath my radical, and basically I need a pair to take them out, so I have a pair of 7s. They move to the outside, and then I'm left with 7 radical 3. So radical 147 simplifies to give me 7 radical 3. Okay, 320, looking at that. Okay, I could do this for a very long time. I'm going to find two numbers that multiply to give me 320. Let's say 32 times 10. Okay, when I do 32, I have 16 times 2. 2 is a prime number. With 16, I'm going to do 4 and 4. Okay, I could break these down further, but I'm looking for pairs. And here I found a pair of 4, so I'm just going to circle these so I can put them underneath my radical. And then 10 is 5 and 2. 5 is prime, 2 is prime. So now underneath my radical, here are the numbers that I have. I have 2 2's, I have 2 4's, and a 5. So I'm going to take my pairs out. I have a pair of 2's that goes on the outside, a pair of 4's that goes on the outside, and a 5 that goes on, that stays inside. So I have 2 times 4, because I took my pairs out, radical 5. The numbers that are outside together multiply. 2 times 4 gives us 8. 5 is inside by itself, radical 5. If I did have a number inside with 5, I'd multiply those. So any numbers that stay inside get multiplied together. Any numbers that go outside together get multiplied. Number 3, we have 2 times radical 6 squared. Okay, squaring something means multiplying it by itself, so I'll have 2 radical 6 times 2 radical 6. My rules for multiplying is outside by outside, inside by inside. So 2 times 2 is 4. Radical 6 times radical 6 is radical 36. And then I'll simplify that. Radical 36 is 6. So I have 4 times 6. Simplifies to give us 24. Okay, so that should be a review of simplifying radicals. This up a little bit. Okay, so here we're going to use that. It says find the missing side of the right triangle using Pythagorean theorem. Leave your answer in simplest radical form. Okay, so basically what that means is don't use a decimal when we find our answer. Okay. So you might be able to use your calculator a little bit, but please don't put your answer so that it's the decimal. So here we have a right triangle. We can solve this. A squared plus b squared equals c squared. That's Pythagorean's theorem. Remember that means c is the hypotenuse, a and b are the legs. So in this case we'll have 8 squared plus 12 squared equals c squared. That's 64 plus 144 equals c squared. It's 208 equals c squared. So we want to find out what c is, so we're going to take the square root of these numbers here. Okay, I'm going to start my tree here. That gives us 104 times 2, 2 is prime. 52 times 2, 2 is prime. 26 times 2, 2 is prime. 13 times 2, they're all prime. So how many pairs do I have? I have 2 pairs of 2. 2 times 2 is 4. and a 13 that doesn't have a pair, so it stays inside. So 4 radical 13 is our answer for the hypotenuse there. Okay, for our second example, notice that they're giving us the hypotenuse. The hypotenuse is 2 radical 21. We can call this A and B. Okay, and we're really trying to find that B side. So A squared plus B squared, which I'll just say S squared, equals C squared. Okay, squared. Make sure when you do this in your calculator that you, first of all, kind of have an idea of what the number should be. If you do this wrong in your calculator, I think you'll get 42. So in your calculator, what I would recommend that you do is put this in parentheses and then square it, like I'm doing on the paper. So here we have 36 plus S squared equals, and when we square 2 radical 21, okay, 2 radical 21, okay, 21 times 21, well, I don't know what that is, but I know if we multiply a radical by a radical, that should give us 21. It should basically drop our radical, just like it happened up here. Radical 6 times radical 6 was 6. Okay, 2 times 2 is 4. So 2 radical 21 squared gives us 84. Subtract 36 from both sides. S squared equals 48. And so the square root of 48, because we want to find out what S is, 16 times 3, 4 and 4. Pair of 4s, 4 goes out, the 3 without a pair stays inside. Alright, so that should have been mostly a review of how to use Pythagorean's theorem. That could be helpful for us in the next couple of sections, and it's definitely going to be helpful for us to be able to write our answers in simplified radical form, since a lot of times they'll ask us to do that. Here's some new stuff, some vocabulary. The geometric mean of two numbers. So the geometric mean is the average, or mean, of the two numbers after you multiply them. Okay. To find the geometric mean, you need to set up a proportion. We'll do that in these next two. Okay. So here's how we do it. To find the geometric mean of 2 and 50, we set up this proportion. So geometric mean of 2 and 50, our geometric mean will be the number x that makes this proportion true. So the number x that makes this proportion true. So to solve this proportion, we cross multiply. 2 times 50 is 100. X times x is x squared. It is not 2x. It is x squared. Okay. And then we take the square root. Okay, and then we find out that x is plus or minus 10. Positive or negative 10. Okay, because 10 times 10 is 10, and negative 10 times negative 10 is 10. So both of these are possible solutions when they're asking us about a geometric mean. Now if we need to find the segment length, or this is solving a problem, remember that there's not a lot of times that we're going to be able to have a negative length. Not any times that we're going to have a negative length, but when we're just solving it numerically, positive and negative outcomes are possible. Okay, we can do this here for 5 and 15 as well. So we're asked to find the geometric mean between 5 and 15. So 5 over x equals x over 15. Cross multiply. That gives us 75. So x squared equals 75. Take the square root of both of these. And then that's 25 times 3. 5 times 5. So x equals plus or minus 5. The pair of 5's come out. Radical 3. 3 doesn't have a pair. Okay. Alright, flipping to the back side. Looking at this now to find similarity in right triangles. So we talked about using Pythagorean theorem. We've already looked at geometric mean. And now we're going to look at setting up similar triangles. Okay? So here it says, redraw and label 3 right triangles from this diagram. Here, notice the 3 right triangles. You have this one here, small one to the left, the medium one here on the right side, and then the large one, the entire thing. Okay, that's our large one. So I want to redraw these. Okay, here, medium here, and then the large one, just trying to redraw them so that they all look how they looked. Okay, and here's our right angle. This one's not drawn as a right angle, but it has to be because of the linear pair. Okay. Alright, so this is A, this is H, this is R. This is H, this is S, this is B. For the large triangle, this is C, this is A, this is B. Okay. So I'm going to label these sides. Notice for all these, the hypotenuse should be pretty easy to find, right? It's across from the 90-degree angle. Hypotenuse, and here's the hypotenuse. Okay, hypotenuse is always across from the 90-degree angle. You'll notice that for medium triangle, B is the hypotenuse, and the large triangle, B is the side. Okay, so make sure that you don't say, oh, this is B and this is B, so they match up. No, it's the hypotenuse that matches up. Okay, I'm going to call this the short side. There's not really a whole lot of ways that we can, or well, without an angle, we can't really say what the short side is, but visually here, pretty easy, so I'm going to label these the short side. And then I'm going to call this other one the long side. Okay, I know it's not as long as the hypotenuse, but there's a long and a short leg. Okay, and so this will be the long. Okay. So notice that each triangle has 3 sides. A short leg, a long leg, and a hypotenuse. Okay, so we did all that. So now it says, now using your redrawn triangles, find the missing side in each proportion. So here we have R over H. What we're going to do is we're going to find out, okay, R over H, which triangle has these two? What legs are they talking about? So the triangle that has R and H is the small triangle. Okay, notice that that's the short leg over the long leg. Okay, and so we want to find out, because they're asking us to finish this, in what triangle is S the long leg? S is the long leg in the medium triangle. Okay, so to finish this correctly, we need to say, what's the short leg in that medium triangle? And the answer is H. H is the short leg in that medium triangle. So H would be our answer. Okay. Again, RA. RA, which triangle has R and A in it? It's the small one. Again, R is short. A is the hypotenuse. They're asking us to finish this, and they want us to find out how to finish this with A as the short leg. And so we need to say, okay, in which triangle is A the short leg? In the large triangle, A is the short leg. Okay? So we need to say, in that large triangle where A is the short leg, what is its hypotenuse? And its hypotenuse is C. So R over A is the same as A over C. Okay. Number 3. We have S over something equals B over C. So again, well here, notice that they switched the sides up and they gave us the completed fraction on the right side, or the completed ratio on the right side. We can keep our same thought process though, okay? We need to find out which triangle has B and C. The large triangle has B and C. Notice that B is our long and C is our hypotenuse. So as we set up that ratio, long over hypotenuse, and we know that in our unfinished proportion, our ratio, we have S over something. So we need to see, where is S the long side? So S is the long side in the medium triangle. Its hypotenuse would be B. Okay, try number 4. Bring that completed. So try number 4. Bring that completed. Make sure you understand. Okay. This last one, we're going to apply these drawn triangles to this situation. So it asks us to separate and redraw and label the triangles, then set up proportions to solve for the variance. So let's do that. We have a small triangle, we have a medium triangle, and we have the large triangle. So our small triangle, I'm going to draw here. We have y, x, 4. Okay, this is going to be a 90-degree angle. Our medium triangle, we have 5, y, nothing's written there, 90-degree angle here. And then for our large triangle, we have large triangle. Here's our 90-degree angle. This is x, and this side is 9, and this side there's nothing drawn. Okay. All right. So we want to find out what x and y are. We're going to have to do this by looking at what sides we have and where we can find our values. Okay, so just like we did before, it's going to be probably an important step for us to label our sides. Okay, x is the hypotenuse here, 4 is the short side, this is the long leg, and here this is our hypotenuse, 9 is our hypotenuse. Okay, our short leg in the medium triangle looks to be y. This is our long leg. And then x looks to be our short leg in our large triangle, and our medium leg is unknown, our long leg, sorry, is unknown, but I'm just going to label it anyway. All right, so as we're looking to find out what x is, or y is, whatever we're looking for, it's probably going to be important to say, okay, where is x? X is in our small triangle and our large triangle. Okay, in order to find x, we want to make sure that that's the one variable in our proportion, right? Because if we have two variables, we won't be able to do it. So I'm going to say, okay, what sides do I know, or do I want to find out in the short or the small and large triangle? And we'll notice that in the small and large triangle, x is the hypotenuse, and I know the hypotenuse. X is the short side, and in the small triangle, I know the short side. So it looks like I can set up a proportion with the hypotenuse and the short side to find x. So I'm going to put the hypotenuse over the short side, and so I'm going to use my small triangle hypotenuse x, short side 4, and in the other triangle I'm going to use my hypotenuse 9, short side x, and now I have a ratio with just x and some numbers. I should be able to solve this. Cross multiply, x squared equals 36, take the square root, and x equals, we can say plus or minus 6, but in this case we're talking about a side length. Okay, and so we can't have a negative side length. So x will be just 6. A little bit. Okay, now we can try the same thing with y. With y, looking at the medium triangle, where y is present, we have the short leg and the long leg. Short leg and long leg. Okay, so it's probably an indication that we're going to need short and long as our, I'll do long over short, as our ratio. Really doesn't matter how you set that up, short over long or long over short. I'm going to do long over short here. Okay, And so in our other triangle, notice that y is our long leg and we know the short leg. So we're going to use probably the small and the medium triangle here. So as I set up the medium triangle, long over short, I'm going to do 5 over y. Okay, and then for my small triangle, long over short, y over 4. And now I cross multiply just like I did last time. Y squared equals 20. To find out what y is, I need to take the square root. 4 and 5, 2 and 2. And I find out that y is 2 radical 5. Again, if we were just solving this as a numerical problem, we'd say plus or minus 2 radical 5. But because this is a side length, it can't be negative, so 2 radical 5. All right, so there we go. That's similarities in right triangles. We set up ratios. We used the geometric mean. We reviewed simplifying radicals. See ya.